Hi. In the last session, we have discussed about homogeneous linear differential equations with constant coefficients. So before we move forward to non-homogeneous equations, we'll consider a special class of equations which could be solved by using the methods we have already discussed. Okay, so such equations are called Euler-Cauchy equations. Okay, so it is actually similar to our homogeneous linear coefficients, but there are some differences there. So we'll use those methods to solve this type of Euler-Cauchy equations. Usually these equations arise in applications in modeling Laplace equations and also while modeling some computer search algorithms. Usually you can encounter these type of equations. Okay, so we'll use these methods which we have already devised for solving homogeneous linear second order differential equations to solve this type of Euler-Cauchy equation. So what is an Euler-Cauchy equation? Okay, so you have already studied the solution techniques of equations of the form y double dash plus a y dash plus by is equal to 0. I hope you understand that. Okay, for that what will you do? First you will write the characteristic equation which is lambda square plus a lambda plus b is equal to 0. Then you will find the roots of this lambda. If the values of lambda are distinct, you know the solution is y is equal to e raised to lambda c1 e raised to lambda 1x plus c2 e raised to lambda 2x plus x etc. And similarly, if it is equal, you know what to do, and similar if it is complex also, you know the solution methods. Okay, so that is the method which we are already studied. Okay, now Euler-Cauchy equations are equations of the form. You can see this is the form of the equation, that is it will be x square y double dash plus x into y dash plus some y. Okay, so that means for every derivative of y there will be a factor of x included there. Okay, so this is actually a second order Euler-Cauchy equation. So generally if it's a third order, it will be like x cube into y triple dash. Okay, for every derivative of y there is a factor of x coming there. Okay, plus some constant. So if you are considering some constant into x square into y double dash. Okay, plus some constant into x into y dash. Okay, so plus some constant just y, because there already we are associating only x only with basically the derivatives of y. Okay, so this is the general type of things. So we will only be considering the second order one. Okay, so general second order homogeneous equation was y double dash plus some a into y dash plus by is equal to 0. This we already know. The Cauchy Euler equation has a slight difference, is that their coefficients are not constant. It will contain x, and also it has a specific form that it is actually of the form x square y double dash plus some constant into x y dash plus b into y is equal to 0. Okay, so just remember, for every derivative of y there is a factor of x coming there. So how will you solve this? So you can actually bring this into this form by a simple substitution. Okay, so what will we do is that we will actually bring this into this form by a simple substitution for x, and then we will solve that converted from our transformed equation, and from the solution we will read back the solution of this equation. Okay, so that is I am going to give a substitution for x this. So when I give a substitution for x, this will actually be transformed into an equation of this form. And once you get an equation of this form, I hope you know how to find the answer by writing the characteristic equation. You can find the roots and then you can write the solution. Once you write the solution in that converted form, you can then read back the original solution by giving back the value of x. So that is the idea which you are going to do here. Okay, so before I introduce the substitution, let me introduce a new operator called a new notation. Okay, so a differential operator called d. Okay, so and from here onwards I will be using this notation in many cases. So this d means d of y basically means simply dy by dx. Okay, so this d means it is simply d by dx. Okay, and similarly if you have y, if it is y dash, it is actually dy. If you have y double dash, I will use the notation d square. Okay, so it will be d square. So d square of y, that means actually it is d square means d square y by dx square. So that is the notation which you are using. So d square is actually not d square y, it's basically it's an operator. So it is defined as simply d square by dx square. So I hope you understand this notation. So what will be d cube? So d cube is the differential operator d cube by dx cube. So that we are going to write this in shorthand notation like this form. Okay, so if I have an equation like, for example, let us play with this notation a little bit. Suppose I have an equation like y double dash plus 5y dash plus 4y is equal to 0. Can you write it in d form? So this can be written as d square y plus 5 dy plus 4y is equal to 0. Or if I take factor out y outside, it will be simply d square plus 5d plus 4 of y. Okay, it is actually of y because this is an operator, so there is no meaning for d square, so it will always have to operate on something. So we will call this as d square plus 5d plus 4 of y. Why? Because it's an operator, because this d is an operator. Okay, so we can't simply say y of d. Why? This has no meaning. This will have meaning only if it is of the form d of y. Okay, there's y of d has no meaning, yd has no meaning. Okay, just understand that. Okay, and similarly if I give you one more equation, for example, if it's y double dash minus 7y dash plus 3 is equal to 0. Can it write it directly? So you can write directly as d square minus 7d plus 3 of y. So I hope you understand this notation. Okay, so if you know this notation, if you have understood this notation, okay, what I am going to do is that if I suppose I have a Euler Cauchy equation. Okay, so I have an Euler Cauchy equation of the form x square y double dash plus a into x y dash plus b into y is equal to 0. Okay, and suppose my d is actually d by dx. Okay, what I am going to do is that I am going to put a substitution x is equal to e raised to z. Okay, I am going to substitute x is equal to e raised to z. Okay, so if I substitute this, what will happen is that my dy, that is actually my dy by dx, will actually be, so this dy by dx. Okay, so if I consider this, so in this equation we will have the quantity of x dy, right? Okay, it has the quantity called x y dash. So in this equation there are terms called x dy by dx. This will be simply be transformed into dy by dz. Okay, so x dy by dx will simply be transformed into dy by dz, and similarly in this equation there are terms involving x square y double dash. Okay, so that is, there are terms containing x square d square y by dx square. It will be transformed into simply d into d1 into d1 minus 1 into y, where d1 denotes d by dz. Okay, so that is the idea here. So you may think it's very strange. It's a very simple thing. For example, I'll just derive it for you. The derivation is not needed for you, but still I'll just derive it for you. Okay, suppose your x is equal to e raised to z. Okay, then you can write your log x is equal to z. Okay, suppose you have to find dy by dx, you have to write in terms of dy. So again I am going to change the independent variable into that of z. I am going to change the equation, this equation into an equation involving y and z only. Okay, so I am going to change the independent variable in this equation. Okay, so what I will do is that I will just change this dy by dx into dy by dz. For that, what will you do? You know, by chain rule, it is dy by dz into dz by dx. Okay, what is dz by dx? Since log x is z, dz by dx is actually, if you take 1 by x is equal to simply dz by dx. If you take the derivative with respect to x on both sides, it will be simply 1 by x is equal to dz by dx. So we will get this as 1 by x into dy by dz, or as I told you, your x dy by dx is simply dy by dz. Okay, so if I call my if I call d as simply d by dx and d1 as simply d by dz, I can write in shorthand notation as x dy is simply, what is it? It is now just d1y. So why is it so? Because it is, you have now derived it as x dy by dx is equal to simply dz by dx. I just wrote it in shorthand notation only. Okay, I am writing it in shorthand notation so that you can find the associated homogeneous equation easier, or characteristic equation in an easy way. That's why I am just writing it in shorthand notation. So when you do the problem, you will understand the notation. Okay, and similarly, if you want to find, so now you know that the value of dy by dx, also now you know this value, this quantity now. Okay, so if you want, you can just try to find out how will you write d square y by dx square. Okay, so d square y by dx square is simply d by dx of dy by dx. Okay, and what is dy by dx from this equation? It is simply d by dx of 1 by x into dy by dz. Okay, now if you apply the product rule, you can easily find the answer. That is derivative 1 by x is simply minus 1 by x square into dy by dz would be there. Okay, plus again so the first function to the second function, so it will be simply d by dx of dy by dz. Okay, so that is your d square y by dx. So these are basically elementary calculations. The derivation is not required for you, but I'm just showing you for your information. Okay, that's it. Okay, so it's simply minus 1 by x square into dy by dz. I'm just going to convert this in terms of z, so it will be simply 1 by x into, I can write it as d by dz of dy by dz into dz by dx, applying the chain rule application there. Okay, so that is, you are getting this as, so what is dz by dx? Already you have know that dz by dx is simply, you know it from here, that dz by dx is simply 1 by x. So will be, in effect you will be getting this as simply minus 1 by x square into dy by dz plus 1 by x square into d square y by dz square, because this will be simply d square y by dz square, and this is actually 1 by x. So when you write it in short form, if I take this x square to other side, we will get this as x square into d square y by dx square. This is the term which is coming in our equation. Okay, so this is actually equal to, if I look at here, it is simply d square y by dz square minus simply dy by dz. So if I use the d notation, it is simply d1 square minus d1 of y, or simply I am writing this as d1 into d1 minus 1 of y. Okay, so your x square dy square y by d square will be transformed to this one. Okay, so remember the notation you have to. So for examination purpose, you need to just remember two things. What is the substitution for x? If the substitution for x is equal to e raised to z, then you can write this substitution will convert your x dy by dx to simply d1 of z, where d1 is actually d by dz. Okay, similarly x square d square y by dx square will convert this into d1 into, sorry, it is d1 of y, sorry, so d1 into d1 minus 1 of y. Okay, so that is the thing you have to write in the examination. Okay, so this I have just told you to how just show it to illustrate how the results has come. For examination purpose, you need to remember only these two identities. From with that you can convert the entire equation. Okay, suppose I am giving an equation. For example, I am giving you an equation of the form x square maybe d square y by dx square minus 2x dy by dx plus maybe y is equal to 0. You can just give a simple equation, or I can write in other notation as x square y double dash minus 2xy dash plus y is equal to 0, being asked to solve it. Okay, so now if you look at this equation, this is equation a homogeneous equation, but it does not have constant coefficients because x square is there. And if you observe closely, for each derivative of x, the derivative of y, there is a factor of x coming, so it is a Cauchy Euler equation, okay, or Euler Cauchy equation. Okay, okay. Now what will I do? My substitution is simply x is equal to e raised to z. When I substitute it, what will happen? This equation will convert into d1. Okay, so I'm just writing it together. So maybe if I can write as d1 square of y, okay, minus sorry, it's not d1 square. So x square y double dash will be converted into d1 into d1 minus 1. Okay, so remember that d1 into d1 minus 1 of y minus 2 into d1 of y plus y is equal to 0, where your d1 is simply d by dz. Okay, so when you simplify this, you will be getting this as, so if you can write this, this will be simply d1 into d1 minus 1 minus 2 d1 plus 1 into y. Okay, I can write it together. Okay, now this, if I simplify this, this will be simply d1 square, again minus d1 minus 2 d1, so minus 3 d1 plus 1 into y. Okay, now this is actually of the form a homogeneous linear differential equation with constant coefficient. You know how to solve that. What will you, how will you solve that? It's simply you write the Cauchy equation, that is simply lambda square minus 3 lambda plus 1, find the roots of lambda. Okay, so simply find the roots of lambda. Suppose your roots are lambda, I'm just writing it, it's not correct, but simply I'm writing it. Suppose your roots are simply lambda is 1 and 2. Okay, so how will you write the solution? Your solution will be written as y is equal to c1 e raised to, if it was in y and x, you will write it as c1 e raised to lambda 1 into x. Okay, but in this case, since the independent variable is z, you will write this as simply c1 e raised to lambda 1 into z. So it is simply 1 into z plus c2 e raised to 2 into z. So we will have to write this, don't forget to write that. Okay, so once you have, so this is actually the solution of the transformed equation. You need to find the solution of the real equation. So what will you do? You give back the value of z. Okay, so your x was taken as, your x was taken as e raised to z, so your log x would be z. Okay, so if you give that solution, the final solution would be simply y is equal to c1 e raised to log x plus c2 e raised to 2 log x. From that you can simplify that, since e raised to log is 1, you will get this as simply c1 x plus c2 x square, because e raised to log x I can write as e raised to log x square, so e raised to log will be cancelled out to 1, so we'll get a simplest. So this will be the solution. Okay, so that is the solution technique for this one. So I hope you understand the steps involved. What are the steps involved? First you identify it as a Cauchy Euler equation, then you substitute x is equal to e raised to z. Don't need to try the derivations once again. You can just write down x square d square y by dx square is simply d1 into d1 minus 1 now, and your x dy by dx is simply d1 into y. You can substitute it there. Okay, substitute and then simplify in terms of d1. You will get a basically homogeneous linear differential equation with constant coefficients. From there you find the solution, and that solution will be in terms of z, then give back the value of z. So that is the general method. Okay, now let us do a problem. Okay, so let us do a problem to understand this problem. Okay, so suppose you have a question like this. Okay, so that is, suppose you are given the question like x square into y double dash minus x into y dash minus 9y is equal to, so we have to solve this one. Okay, so I'll write it here once again. So that is x square into y double dash minus x into y dash plus 9y is equal to 0. That's the problem given here. Right? Is that right? Okay. X double dash x square into y double dash plus x into y dash minus 9y is equal to 0. Okay. So it is plus x into y dash minus 9y is equal to 0. Okay. So first of all, the first step you have to do is that you have to check what is this equation. If you look at this equation, this is a homogeneous equation, but it does not have constant coefficients, but it has that factor of x is coming for each derivative, so it is actually your Euler Cauchy equation or Cauchy Euler equation. Okay, so that is of that form. Okay, so what will you do in that equation? You either give the substitution x is equal to e raised to z. So once you give the substitution, what is your x square y double dash? That is actually d1 into d1 minus 1 into y, or you can simply write d into d minus 1 if you can understand what is the meaning of d. Okay, that's also fine. Okay, so I am just giving d1 so that you will not get confused with d and d1. So d1 is simply d by dz, and similarly your x y dash will be now just d1y. Okay, now substitute everything into this equation. Let me number it as 1. So what will you get this? So what is the meaning of this now? So when you substitute, what will you get? It's simply d1 into d1 minus 1, y I am taking it outside, I'll keep it outside later, plus d1, okay, minus 9y. So I have done it together. Okay, so if you want, you can use this step also, d1 into d1 minus 1 into y plus then d1 into y minus 9y, then you can take y outside, but I am taking it together. That's it. Okay, so this is the equation. Let me simplify this one. So this will become d1 square minus d1 plus d1, so it will be d1 square minus 9. Okay, so d1 square minus d1 plus d1, so d1 square minus 9 is equal to y is equal to 0. Okay, so this is actually a linear homogeneous equation with constant coefficients. So the characteristic equations of the form lambda square minus 9 is equal to 0. From that I will get the value of lambda is plus or minus 3, right? Okay, so if I get that equation, now maybe I can write the solution as y is equal to c1 e raised to, remember 3, it is not 3x, it is simply 3z plus c2 e raised to minus 3z. Okay, don't write 3x because if you have the independent variable is actually z only. Okay, so now I am going to give the values. Your x was actually e raised to z, so z is simply log x. So when I give that value, I will get this as y is equal to c1 e raised to 3 log x plus c2 e raised to minus 3 log x, or simply it is c1 e raised to log x whole cube. So it is e raised to log x cube plus c2 e raised to log x raised to minus 3. Now this e raised to log is basically 1. So you will get the answer as y is equal to c1 x cube plus c2 x raised to minus 3. So that's the solution. Okay. In the textbook, they have actually given this formula itself. Okay, so in the textbook they have told you that if the formula is basically the roots are lambda 1, lambda 2, without going to these details, they are giving you the equation solution as simply y is equal to c1 x raised to lambda 1 plus c2 x raised to minus lambda 2. So if you want, you can study that formula itself, but I don't want to confuse you. That's why I just showed you how to derive this formula. Okay, so this method would be better to remember, otherwise you will have to remember a lot of formulas. Okay, now all the cases involving complex roots and also the equal roots, all will apply here also. Suppose your roots are actually 3, 3. In that case, what will be the solution? If it was simply 3, 3, your solution would be y is equal to c1 e raised to 3z plus c2 z e raised to 3z. So same case will be applied here also. So then you can give the value of z. Z is basically log x. So in that case you will get this as c1 e raised to 3 log x plus c2 log x e raised to 3 log x. From that I will get the answer as c1 x cube plus c2 x cube into log x. Okay, so in the case of equal roots also the same thing will be there. Find the solution in terms of z and you give back the value of z as log x. Okay, similarly you can also consider the case when the roots are simply a plus or minus bi. That also you'll have e raised to y would be e raised to az. Okay, instead of ax will be e raised to az into c1 cos z plus c2 sin z. So in there you can give the value of z. Now that will be simply e raised to a log x, okay, into c1 cos, there will be term of log x inside cos, you can't do nothing, you can just keep it like that, again plus c2 sin log x. So that will be the case of complex roots also. So I hope it is clear. If you know how to solve the homogeneous linear equations, you can solve all these problems, and also additionally they can ask you initial value problems also to find the c1 and c2. They can give the value of y of 0, y of 1, etc., etc. So that also you can consider. So I would collected, so I'll have illustrated two problems here, and I have collected all the problems out here. Okay, I hope you can do all this one. Okay, so just check out these problems. I'll give some homeworks. Please try to do that. I also hope you understand how to do this one, also initial value problems also. Suppose this is the equation. Again, you can see that it's an Euler Cauchy equation together with an extra conditions. There also it's very simple. What will you do? What give the substitution as x is equal to e raised to z. So your equation will become d1 into d. I'm talking of question number 12. So it will be simple d1 into d1 minus 1 minus 4 d1. Okay, plus 6 into y. Now simplify it. It will be simply d1 square minus d1. So it is minus 5 d1 plus 6 into y. So when you solve it, so you will have the characteristic equation as lambda square minus 5 lambda plus 6 is equal to 0. From there, you will get the value of lambda as 3, 2. So your solution is y is equal to c1 e raised to 3z plus c2 e raised to 2z. Okay, now you can write in terms of x. So that is y is equal to c1 e raised to 3 log x plus c2 e raised to 2 log x. So it will be simply c1 x square x cube plus c2 x square. So y is equal to c1 x cube plus c2 x square. So once you have got the final solution, only then go for substituting these values, because all these values are given in terms of x only. So don't substitute this y of 1 is equal to 0, y dash of 1 is equal to 0, etc. into this one, because that is not a solution. This is the solution. Only substitute the initial conditions in the final solution. Okay, so you have been given that y of 1 is 0.4. So you substitute it there. So when you substitute x is equal to 1, you will get this as c1 plus c2 is equal to 0.4. Okay, similarly y of y dash of 1 is 0. So you take y dash. When you take y dash, it will simply c1 into 3x square plus c2 into 2x. Okay, so you substitute x as 1. So you will get just 3c1 plus 2c2. That value is given as 0. Okay, so you consider these two equations and then solve it. So you have 2c1 is there plus 2c2 is equal to 0.8. I'm taking this equation, so use it, you will get the value of c1 as simply minus 0.8. Okay, from that you can also find the value of c2. Okay, so that will be, maybe I think it's 1.2, so c2 will be basically 1.2. Okay, so please try to do that also. Okay, so I hope it is clear. So you can check these problems here. So all the equations are actually Cauchy equations only. So there is one equation which is standing out. If you had observed closely, if you look at this problem here, okay, if you have observed this problem here, that is actually, it's not a Cauchy equation, Cauchy equation. It can actually become brought into Euler Cauchy form equation by just multiplying into the x. Okay, and multiplying this with x will not change the solution because it's a homogeneous equation. So it will not affect the solution because your RHS is 0. So if you want to find the solution of this one, you can simply find the solution of x into that one, that is simply x square y double dash plus x y dash equals 0. It will not change the solution because it is of the form x into something only, and this right hand side is homogeneous one, it's 0. So this x factor will not affect the value of y there. So no issue there. So then you can find the solution, that also. So that's a special case here. Okay, you can try that problem. Okay, so other problems are very straightforward. I hope we can do that also. Okay, that's it. Okay, thank you.